Okay, so now that we know how to calculate the C-score, let's actually use the C-score. Let's find probabilities. Just as a little reminder, I showed you guys a little graph yesterday, and then I said the normal distribution, it comes out as look like a bell. Now probability will be the area under the curve, okay? So let's take a look. Suppose that the scores, which we're going to call X on the college entrance examination, are normally distributed with a mean of 550. Okay, this number might be important. This is the mean. So let me just write it. Let me call this mu. Remember, mu's are mean. And the standard deviation of 100. Okay, so this is important. Let me use the number sigma. Just as a reminder, our C-score, we talked about it. The way we're going to find our C-score is going to be X, the number we're checking, minus mu, and all of this divided by sigma. Okay, so find the probability that the student gets at most 523. Okay, so this will be my X. My X is 523. Let me figure my C-score. Every time I'm going to look for probabilities, I do need my C-score. In this case, I'm going to go 523 minus 550. All of this divided by 100. Remember, it's X minus mu divided by sigma. Okay, so 523 minus 550 divided by 100. I end up getting that my C-score happens to be negative 0.27. Okay, so let's go back. So looking at our figure, let me draw my bell shape. Right here in the center, that's where we're going to have mu. But it says I'm going to go to the left because it's minus 0.27 standards deviation. So somewhere about here. So find a probability that that happens. I would like to know this area. So let's use our table that we used yesterday. Okay, so now looking at our table here, I know all of our values are positive if I'm looking at a negative 0.27. So let me ignore the sign for right now. So I'm just going to look at 0.27. So here's 0.2. Let me come on with this. Let's see. So here I see 0.2. And then here's 0.07. So 0.27, it's right here. 0.1064 according to our table. But what does that mean? That is this area from mu to our C value. So 0.1064. Let me remember that number. Let me come back to our work here. So let's remember 0.1064. Let me do this in blue. This area is 0.1064. Okay. But this goes up to 0.27, right? But I do need negative 0.27. Well, the area to the right of mu will be the same to the left. Let me say this area in blue here, it's also 0.1064. Okay. Now, I'm not interested in the area in blue. I'm interested in the area in black. So let me just focus at half of my graph. I know the whole half of my graph is 0.5, right? Half of probability, so 0.5. So that red and that blue combined is 0.5. I know the blue is 0.1064. So for me to figure out how much is red, the red section, shouldn't I go 0.5, which is the whole thing, right? Once again, when I say the whole thing, I'm just looking at this half of my graph minus the blue section, which is 0.1064. Use a calculator if necessary. According to my calculator, that is 0.3936. Okay, that's pretty much it. The probability that someone will get at most 523 is 0.3936. One thing that I want to emphasize, the word at most, the phrase at most. At most means to the left of it, right? There we find our C-score and we're looking for information to the left of it. I might also use at least. At least is to the right of it. So at most is we're looking at area to the left. Okay, that's not that bad. Let's take a look at the next question. Find the probability that a student gets between 500 and 630. Okay, so let me do my graph here. I know my mu, right in the centered, is 550. I want to know what's the chance that a person gets in between 500 and 630. Okay, so I'm going to do this as two different questions. Let me find my C-score for each of them. For the 500, again, I'm looking at my Z-score. I'm going to go 500 minus 550 divided by 100. Remember, we always go X minus mu all divided by sigma. So that's not that hard. It's negative 0.5. Okay. Let me get my other C-score. I'm going to go 630 minus 550 divided by 100. Again, I'm interested in my C-scores for right now. 630 minus 550, all of this divided by 100 is 0.8. Let me use my chart. When I mean chart, I'm talking about this thing. Okay, I know my first C-score was a negative 0.5. Okay, so negative 0.5 is right here. Oh no, negative 0.5. Let me see, not that. 0.5, it's right here. Because this is 0.500 or 0.50, okay? Okay, let me remember this number. 0.1915, okay? Let me just go here, 0.1915. Okay, what does that mean? To the left of this is the probability 0.1915. Okay, that's not bad. I'm not going to show my chart again, but I'm looking for 0.8. If I go to my chart, 0.8 is 2881. Okay, what does that mean? 2881. So I have 0.2881. That is this section. Okay. Oh, actually, let me go here. My 0.1915, it was the distance from my mu. So it's that section. Okay. So shouldn't I just add these two areas? I'm gonna go 0.1915 plus 0.2881, and I get 0.479. 4.96. Once again, the areas, according to the chart, is the distance from the mean. So the distance from the centered. I got two different areas. I just combined the two areas, right? I added the two numbers, and my answer is 0.4796. Be careful on the instructions. Our table gives it to us to round it to 4 decimal places. Now in the instructions, I might ask you rounded to 4 decimal places, which is there. I might ask you rounded to 3 decimal places. I might ask you to round it to 2 decimal places. So do pay attention to the instructions. Okay. This one I rounded to 4 decimal places, but once again, I can ask you to round it to 3 decimal places. Okay, so let's take a look at here. Suppose that scores X or values are X on a college entrance exam are normally distributed with a mean of 560. Okay, so 560 is important, is the mean. So let me just write my mu here. And my standard deviation of 90. Okay, so here to the 90, let me write sigma. So that's my standard deviation. There's a certain prestigious university that will consider for admission only those applicants who scored exceed. So exceed is a fancy word, means more than. So you're better than the 90th percentile of the distribution. Okay, so only if you're in the top 10%, right? You're better than 90%. Find the minimum score an applicant must achieve in order to receive consideration for admission to the university. Oh, okay. Let me take a look at our table here. Looking at our probabilities, when I mean probabilities, I'm talking about these 4 decimal numbers, any of these numbers. I'm looking for the one that is higher than 0.4. Okay, you might be like, where does that 0.4 come from? Okay, so remember our graph, I'm looking at 90%. However, this table only deals with half of the graph. So we're not going to deal with the first 50%. We're looking for the top 40%. Because 50 and 40 combined make 90%. But 40% as a decimal is in that 0.4. So I'm looking at my probabilities, the first probability that is higher than 0.4. So keep in mind, has to be higher than 0.4. So according to this, it's in between these two, right? It has to be more than 0.3997, but it could be less than 0.4015. Okay, so the first number that is higher than 40% is this. Cool, I found my probability. According to that probability, can we read the C-score? Okay, let me help you guys out. There, it's right here and right here. Okay, which C-score gives me that probability? Yep, it looks like 1.29. You guys see that? 1.29. Okay, so my C-score has to be 1.29. All right, let me go back to our work here. Let me write down information. C-scored. I need it to be at least 1.29. Okay, so let's see what's the smallest score that I should be able to get. My mean was 560. So let me just say it. My score has to be 560 plus. Okay, I need to move my standard deviation 1.29 times. So I'm going to go 1.29 times 90. And that should give me my smallest score that I should be able to get. Use a calculator if necessary. I'm just going to say here, this thing gives me 571.61. Cool, that's it. In order for me to be considered into this school, my score has to be at least 571.61. Okay, let me zoom out so you guys can see exactly what we did today. So we're looking at finding the C-score. You guys remember the formula for the C-score, X minus mu divided by sigma. Looking for the C-score using the table to find our probabilities. The table gives us probability from the center, so from the mean, whether we go to the right or to the left, the distance from the mean. There you go.